Okay, in a study, the association between a person's height in centimetres and body surface area in square metres, the following least square was obtained. So which of the following in conclusion is a conclusion that can be made from this least squares line? So an increase of 1 metre square body surface area is associated with an increase of 0. So when we see this, an increase, we want them to be talking about the B value. And so when they're talking about an increase, but they say the body surface, that's actually talking about the response variable. And if we really want to be talking about the B value, so we want to be looking at the explanatory, so that's not. If you look at our definition for when we explain or interpret the slope, we see it's down here, I've popped it in, and it says, as we would say, as the body surface would increase by the B value, which is 0.019. So the body surface when the height increases. So we're looking for something that says that. So an increase by 1 centimetre. So an increase of 1 centimetre in height is associated with an increase of that in body surface area. Well, that's true because we were supposed to put metres squared. So you can see that this one is interpreting, it's a way of interpreting the slope or the B value correctly, so that's good. If we looked at the other ones, this is not the R value, that's the B value, so that's definitely wrong. And a body surface area square can be determined by adding, so this one, they're just being, it's just nowhere near, the 1.1 is the A value, we don't say that. So we definitely found the right answer there. Okay, in this next one, the least squares line is fitted to by data. Another least squares line is fitted where they swap the response and the explanatory around. And which of the following statistics would not change? So definitely the residuals would change, the slope would change, it could move around, but hopefully when you were calculating the R value when we first did that, you notice it didn't matter which one you actually did put on the RV, EV to begin with, it still gets the same value even if you switch them around, but everything else would change, so it's just that one. Okay, question 10. The residuals from the least squares line have a mean of 0.02 and a standard deviation of 0.4. The value of the residual for one of the data points is 0.3. So the standardized value of these residuals. So really all it's doing is a standardized value is a Z-score. Okay, so we're looking to do the Z-score. So you'd hopefully go, all right, and there's the formula. So we're going to say it's actual minus the mean divided by standard deviation. And they're just throwing you using the residual list. So you just think of it like you've got a normal list. So they said it actually had negative 0.03. So you go negative 0.3 minus the mean, which is 0.02, divided by 0.4, and you end up with your answer is A. Alright, so the scatter plot below shows wrist circumference and ankle circumference of 13 people, blah, 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 and they told you the explanatory is ankle. We can see that anyway. Now, they said the equation for this line is, so they want you to get the equation of that line. So we did this in class where we said to get an equation of a line, you need to use 2 points. So I'm going to pick 2 points that line is going through. Now, be really careful. I'm going to use this one here, but this is actually going through, X is 21 and Y is 17.3 or something. Okay, and then I'll use another point that it goes through. So maybe I don't know which one. What do you want to do? Even the
one that it's nicely goes through. I might go through this one and up here. So you can just get your ruler and read off it. It's 18.4. So when I had 24 and 18.4, sorry. All right, so we're going to change this one to 17.4. That's fine. So what I said to do is in your listen spreadsheets, so listen spreadsheets, we're going to pop in a little mini X and Y list. So X is 21, Y is 17.4, X is 24, 18.4, and then you just do a linreg and you get the A plus the B X value, you know, and then you'll find out what A equals and what B equals. What you could do though is you can quickly see that this, because this is not 0, this is not the intercept. So because this is not 0, that is not the A value, yeah? Because that's the intercept. So you could go through, now also this should be Y. So wrist should be something wrist circumference equals. So I'll get rid of ankle. And I know for a fact that A is not 17.4, so I get rid of those two. I didn't even have to work it out. There's the answer. So we've got the scatter plot again. When the least squares line on the scatter plot is used to predict circumference with a person of ankle circumference 24, the residual is. So residual, we're trying to find the residual. So if you just wrote the formula for residual is actual minus predicted. Okay, predicted is the line, okay, and actual is the dot. So if you go to 24 here, so you can see there's the actual. So you could read off what it actually is. So it's got a Y value of 17.7. So we're going to say 17.7 over here. And then I go straight up that line, that 24 line, till I hit the line and I read off that one. And that one is, what is it? 1, 2, 3, 4, 18.4 is the predicted. So what ends up being the residual is, what do we get? A, negative 0.7. Roughly.
Okay, with this question, they said the least regressions line has been fitted, and they pretty much want us to get the equation where we predict distance from time. And we can see that anyway because distance is our response variable and time is our EV. So first of all, we want an equation that says distance equals, so we could get rid of the two time ones. Now, as this is 0 down here on the x-axis, we can say that where the line crosses is the A value, the y-intercept. So we looked at it and it looks about 3.5, but if we look at our two possible answers, they're both saying that. So we need to find what the B value is. So like I've been saying, you can just pop 2 points into your calculator. Sorry, I've cut that off. So I had, when x is 0, we had 3.5, and then I used this other blue point up here, and I said when x was 30, I said y was 50, and then I just did the a linreg, going through menu and the stats, etc., and I have to work out, and I get this B value of 1.55, so I'm going to go with A, it's closest to 1.6.
Okay, the equation of the least regression line is used to predict fuel consumption. So when they say predict fuel consumption, you know that that is your Y, because predicting in kilometres from a car's weight. So that is, so you might say this is response, and from a car's weight, that's going to be your explanatory. The equation predicts that a car weighing 900 will travel 10.7 litres of fuel, while a car, so what it's doing, it's actually giving you two X values. So it's saying when your EV is 900, your RV is 10.7. Yeah, and then it gives you another point. It says when it's 1700, your RV is 6.7. Now they're asking you what is the slope. So the slope is what? What letter do we use for the slope? The B. So you can simply do like what we were doing before when we were trying to get the equation. You could just pop that into lists and spreadsheets again, and like how you've got two little mini lists, so you could just put your X and your Y, and we do the same. Well, we're at 900, 10.7, 1700, 6.7. Do your lin reg and your A plus BX, and you're looking for the B value, which was this question answer here. So B will end up being 0.004 if you do that. So a least squares line is fitted to the data in a scatter plot shown below. The corresponding residual plot. So if you think about what an actual residual is, a residual is the actual minus the predicted. So if we have, remember the actual is, say, the dot minus the line, okay, what it predicts on the line. So if you look here, if you've got here, say this one, the dot was 280 and predicted was 320. So you've got a negative 40. So if your dot is underneath the line, so say this guy and this one, they're going to have a negative residual, aren't they? So if you go down to your residual plot, remember these are the zero, this is the zero line. So we should see the first two should have, well, we worked out the first one, it should be 40. So can you see this one has one at 40? So this one is not, it's more than 40, so I'd get rid of that. That one's more than 40. This one's saying it's a positive, so that's not right. And this one's saying it's only negative 20. So I've already worked out the first one, so it's got to be A.
Okay, so here we get given a couple of measurements for blood pressure, systolic and diastolic. So it's numerical. And down here in the question, they have used the old words where they say dependent variable. So for us, that's the response variable, and they've said diastolic is the independent, so that means explanatory variable. So when you work that out, you should go put them up above the list up here, because they've actually put the response one first, which can sometimes we're used to seeing the X value first, so we just need to be careful there. Now they want us to get the least squares regression line, so we know systolic should be written first, so we can get rid of these two diastolic ones, and then obviously we've got no other choice really to except put them in the calculator. So I've gone and created the two lists and popped them in. Now it said in the blurb up here, which hopefully you can read in reading time, that there were 15 measurements, so that when I got down to 15 I knew I'd typed in enough, so that's, be careful with that. And then I've just gone and done a lin reg, and I've found the A value and the B value. So A is 70.3, so that's the only one there with that option is here. So we can go with that answer. Okay, so when we're asked to do the least squares regression line and we're not given the list of data, we should realize that we're using those other formulas. So these ones. Okay, so we're going to be using these. So we need to calculate the B value, where we can use the R, so to be negative 0.644 times SY, which is there, 3.20, divided by the standard deviation of X, which is there, and we'll get the answer. So we get an answer of 0.7. And if we look down, unfortunately all of them have that. So now we're going to find the A value, where we'll do the mean of Y, which they gave me here, minus the B value, which is 0.7 times the mean of X, which is there, and we end up with a value of 9.2. So we'll end up with the answer of A. Okay, looking at this question here, it says you've got the height versus foot length, and they've created a scatter plot. By inspection, the product moment correlation for this data is, so they want you just to estimate R. So first of all, you can see it's going upwards. So it's definitely not a negative R value, so you get rid of this. Now, 0.23 would be a very weak thing, and the dots won't even be near close to being on the line. And 0.98 is very strong, and we'd see them nearly on the line. So in this one, although it looks fairly okay, strong, I wouldn't say it's super strong, so I would go with the B. Here they've used the independent variable again, where we like to say EV now, explanatory variable. The equation for this regression line is closest to. So we need to, first of all, see one that says height, so we'll get rid of that. Now also, if we want to be quick, we can see that this down here is not the y-intercept because it's 20. So we know for a fact that whatever this one is, 65, 167. So we know for a fact that 167 is not the A value. So if any of them have put that in their A value, we can get rid of that, which two have. So we'll get rid of that. And so now we've got to work out probably our B value or our gradient. So we're probably going to pop them into the calculator and do a little mini listen spreadsheets again, where we'll pick two values. So we might as well use the one we just looked up where it was 20 and 167. And I'm going to use another one. It goes nicely through, and it looks like it's going nicely through 34 and 185. So I'll pop that into the equation, and we'll end up with an A value of, so we'll do a lin reg, and we get an A value of A value of 141 and a B value of 1.3, which is this one. Okay, so this one, this is the original scatter plot over here, and they want you to match up the residual plot over here. So remember, the residuals are the distance between the dot and the line. So this one, so if you wrote the residual equals actual, which is the dot, minus the predicted value. So if you look in this first dot, we're going to say that it's roughly 171. The dot here is 171, but the line predicts it to be, let's say, 168. So 168. So you would see its little residual will be 3. So the first dot should be a residual of positive 3. So if you look here, this one's negative, so we'll get rid of that. This one could be 3, so that's okay. This one is negative, get rid of that. This one's negative, but the first dot here. So it's out of these two. So then what you might want to look at is, maybe what is different about it. So anyway, let's have a look. There's 2 below it now. So if we look at these 2, yep, they do, let's say the next 3 are below, so we should see the next 3 below, but we don't in this one, so we're going to get rid of that one, and we're going to say that B is now the answer, okay, because we see this one and this one there's a residual, and this above one is listed there, and so on.
Okay, so the number of male moths caught in a trap set in a forest and the egg density per square metre in the forest are shown below. Okay, so the number of female moths caught in a trap in a forest, blah, blah, blah. So reading off here, you can see number of females is, they gave you a scatter plot here and egg density. Okay, they told you up here that the egg density, the least squares regression line is here. Okay, so here's the least squares line. Now they want you to draw it on the graph. So this one's really important. You do have to do this in the SAC. So you've got to draw this line onto this scatter plot over here. So what you do is, so the equation is egg density equals 191 plus 31.3 times female moths. Okay, what you're going to do when you're sketching any of them is you are going to pop the X value at the start into the formula. So if you notice, that's starting at 10. That is not starting at 0. So this value, so you put 10 into this formula here. So you've got 191 plus 31.3 times 10, and you'll get a rough, you get an answer. So I'm just gonna, so it's around the, ends up being around the 500. Okay, then you're gonna do the same thing again, but you'll put 60 into the formula. So it'll be 191 plus 31.3 times 60, and you end up with it just being a bit over whatever 2,000. Okay, then you get your ruler and you just line those dots up like that, and you draw it through. Okay, so the examiners will be looking to see, and they checked by seeing that you made sure you went through that dot, because that dot ended up going through it. So that's how you do it. You don't try to go, oh, the A, the intercept. Just look here and put whatever numbers are there. If it's 0, it's 0. You'll get the A. If it's not, you just pop that in. So in the next bit, it asks you to, and there's that golden word, interpret the slope. If you've got an interpret question, it means I would have given you a fill in the blank. So we need to interpret the slope. So I'm going to go to my book and find that. So I'm going to say and I need to put the RV. So the egg density increases by, and I'm going to put the B value, which is 31.3, and I've got to put the RV units, which is meters squared. So meters squared when and I've got to put the E, so the number of female moths increases by 1. By 1, you could say 1 moth, or you can just write 1. Okay, the next question, I'm going to do this one. The egg density is 1500, so that's a Y value, when the female moth is 55, so that's an X value. Determine the residual. So if you write the formula for residual, is actual minus predicted. So when they tell you the egg density was 1500 when X was, or when the female moth was 55, they just told me the actual, they told me it. And now I've got to work out the predicted. The predicted is either the line or you use the equation. So I'm going to use the equation, so 191 plus 31.3 times, and it's going to be, they told me it was the 55 that they want to do. So we work out that, and we end up, the residual ends up being negative 412.5. Okay, the correlation coefficient is 0.862. So that's the R. When you see this, determine the percentage of variation. Determine the percentage of variation. That is talking about R squared. Yeah? So when you see that language, that written, they're talking about R squared. So you just had to square the R value. So square that, and then you needed to change it to a percentage. So it would have been 0.4 743, but they say what percentage, so we'll times it by 100. And you need to be careful. It said 1 decimal place, so you would have, that's why I only did it, because it equals 74.3%. A lot of people would lose a mark because they probably didn't do the correct decimal place.
Okay, so here they've plotted a scatter plot against male life expectancy and female life expectancy. They've given you a bit of the slope is that, so they gave you the B value there. And they've then asked you to interpret the slope. So interpret the slope means that we have a statement in our notes that we can use. Now, because the B value is positive, we're going to use this positive statement. So I will just write, and where it's yellow, we're going to change it to the example. So the male life expectancy increases by, and we put the B value, 0.88, and we put what the RV units are, which are years, when the female life expectancy increases by 1 year. Okay, sorry. There you go. And so I'm just using that our fill in the blank. And then in the next, down in here, I'm just going to jump to C while I'm here. It says interpret the coefficient of determination. So once again in your notes, you'd have that. So we don't even have to do the tells us. We'll just say, we can say that. Now we've got to change, this is already R squared. So we just have to times it by 100. So we're going to say that 95% of the variation in, and we're going to write the response variable, which is male life expectancy, can be, or is explained, or can be explained by the variation in female life expectancy. Female life expectancy. Okay, so I'm just reading the EVs off here and the RV off there because I know that, and doing that. And then just down in this question, down in the prediction B, it says use this equation. So they've got an equation here to predict male life expectancy for the country where female life expectancy was 35. So you're simply just putting that value into that formula. So 3.6 plus 0.88 times 35, and you'll get a value which was 34.4 years.
Okay, the equation for the least squares regression line is given here. Winston is an inner suburb. It has an area of 4 kilometres and a population of that. So really they just gave me a EV there and an RV there. So, and because they sort of gave me, it's given me, that was the actual, yeah? They gave me the actual. So calculate, and then they've told me what the R is. It says calculate the residual when the least squares line is used to predict the population of Winstons from its area. So just write again, they want the residual. They're saying calculate the residual. If you write out the formula, hopefully everything will start making sense. So the actual is they either give it to you or you can read it off. So they did give it to us. So residual is, it actually is 6,900, and the predicted, we've got to use the equation. If we can't see the line, we'll use the equation. So 5330 plus 2680 times the area, which they told us when they gave us the actual, they said it was a 4. So we do 4, and then in there you have your thing, which ends up being, so it ends up being 6690 minus the predicted was 16050. So we end up with a residual of negative 9360. That was the answer. Okay, see here, once again, it says, what percentage of variation? What did I say when they say percentage of variation? What are they talking about? R squared, yeah? So they told you the R up here. They told you in the blurb, the R, so you can just square that. So you go 0.668, square it. So to find R squared, and then we end up with 0.446, but they want percentage, so we times it by 100, and it said correct to one decimal place, so 44.6%.
Okay, so here we've been given a scatter plot, and we can see that development index is the response variable, and we can see that average pay rate is the explanatory because it's on the x-axis. So down here, when it's giving you a table of statistics, so when they write, well, they've been nice and they've called average pay rate, they've even told you that's the x, and they've used the y. So once again, we're probably using those regression formulas, which I'll grab. Okay, so these formulas here. And it does say, use this information to show that the least squares regression line is this. So you've already got the answer, you just have to show the value. So you'll have to just write, well, B equals, and you pop in all those values. So we've got to put the R, so 0.488 times the mean of Y, the standard deviation of Y over the standard deviation of X. And then you just would write what B is in that formula, which is 272. You don't even have to do it on your calculator because they're saying show. So they've already worked it out for you. You just got to show this formula. And then here we've got to put the other data. So we've got the mean of Y, which is 85.6, minus our B value, which is 27.2, times the mean of X, which is 15.7. And then you just write 81.3. Okay, so that's all you have to show for that one. Okay, so once again, this one, they want us to draw the line, so this equation on the graph, up here on the graph. So when you've got one of them, you pick the first x value and the last x value, and you just pop it into the formula and see what you get. So max temp equals 13 plus 0.67 times 0, so you end up with 13. So put a cross on 13, and then we're going to sub x is 20 into it. So when max temp equals 13 plus 0.67 times 20, and we'll get a value. So I get that to be 26.4. So I go up here 26.4 like that. You get a ruler, line up those two dots that you just did, and then you put a line through it, and then a straight line through it, and there you will have the equation. Okay, here in this question we've got another scatter plot, and they've given us the equation, and once again they were asking me to interpret. So if we interpret, we've got to fill in the blanks. And they said the vertical intercept, and that's just another way of saying the vertical intercept is another way of saying the A value. Okay, so here I've gone and found interpreting the A value or the intercept. So we're going to just write that statement out, and we'd say the intercept predicts the maximum temperature to be 13 degrees Celsius when the minimum temperature is 0 degrees Celsius. So I've used the units for the EV, and up here when I had to put the RV units, there it was. And yeah, so I probably should have the regression line intercept. line intercept predicts. Okay, so I'm just simply using that. Okay, so here we've got another scatter plot and the line, and they're asking me to fill in the blank, and it says from the least squares regression line, it can be concluded that for these countries, on average, so this word, when you see this on average, they're talking about the gradient. So that's a word we use for gradient, which means the b value or the slope. Okay, so increases by, so we want to say, we look for that value, and we'll say now we'd say 0.3. Now it's not saying for each $1, so normally we say when it increases by 1, so they're actually saying when it increases by 1,000. So I'll just explain what I mean. So here, like you can see, when we're asked to interpret the gradient, we say, so here we would say the female income increases by, and we'd put like, normally we'd put the gradient there, so 0.35 when the male income increases. Now we just say 1 unit normally, so they're actually saying when you increase by 1,000. So if it increases by 1,000, it means we have to times our gradient number by 1,000, because it's not talking about 1. So when you do that, that means that the gradient's actually increasing by 350. Okay, so that's where we equals 350. So that's where that one. So that one was a little bit tricky, and you've got to be really careful. So that would probably be reading a question, not slipping up there. Okay, this question, they're pretty much just asking you use this regression line and predict the average female income when the male income is 15,000. So you just got to type that in. So that's just like typing in female, use that formula, income would equal 13,000 plus 0.35 times 15,000, because that's what the male income was, and we end up equaling 18,250. So as simple as that. And the prediction in part B is not likely to be reliable. Explain why. So if you look at 15,000, 15,000 would be down here on the range, so it's outside the range. So we were going to say, so making a prediction outside the range is extrapolation and not reliable. Okay.